All right, so in this video we're going to take a look at io streams, io readers, and bufio.Readers. I have a basic kind of skeleton here for something I want to do. That's not to say that this is what you want to do in practice or whatever, but the goal here is going to be write a function that reads all the lines from a file and gives us a slice of them, right? And this seems simple enough. We're going to be taking a look at three different modules for this, or two different modules. So that's io and bufio. And so we're going to build some small functions for dealing with these things. So let's get started. We have a basic test here that we want to pass. I'm going to comment these out just so this compiles, by the way. And so let's say here task watch, task t watch. We can see here that we got 0 lines, and that makes sense. We could potentially, no, let's leave this in that window. We don't have space for this. So we are now returning basically an empty slice here. That's it. When this returns, it's not going to do anything, right? Because we are actually not running any code or whatever, right? So how do we approach this, right? We can start by opening a file. And the reason I say that is because let's actually open our import OS here. An uncomment io, and here we want to open the file, right? So file handle, handle open error, os open, file name indeed oso read only, like this. And the third parameter is a mode. We don't need that necessarily. And so now we have an open error potentially here. And let's just say that we have some read file error union here. We know that there are going to be multiple things here. So let's just say this is a union and we have an open error potentially for now. An open error is going to be a struct with the file name string. This is actually a file path, but doesn't matter so much. The error, let's just say error, we could say reason here, it's going to be os_erno, so on. So you can see that this open error here is that, right? And so if open error is not os_erno or error none, rather, return nil and read file error. Actually open error rather, and this is that. Now we are not saying here that read like this. Handle is declared but not used, that's fine. Lines and nil here, and now we want to use the handle. So what we actually want to do is create what is known as a stream from this. So here we actually want to say stream is io, or os rather, to stream handle, stream from handle. There you go. All right. So this, we can see here that this doesn't actually do much. If we were to peek a little bit into this, we can actually see here that we create a stream. We set the data for the stream to be the file handle, right? So that's this file descriptor. That's why it's called FD here. That's just a number actually internally. And then it sets that in the data field, and then it sets the procedure to use to file stream proc, which is this here. And this does stuff, right? That's actually what's kind of reading from this thing, right? So let's actually take a brief look at what a stream actually is, right? We can see here that it's these two things. We saw these. So we have data here, which is a raw pointer. And so this gets to this describes a pattern that can be very common, or is very common rather, that we're going to take a look at specifically when we're going to extend a reader. We also have a stream proc, which is this here. So a stream proc is any procedure, right, that satisfies this contract here. And here we can actually see that the stream data is coming in as a raw pointer here. And then we have a stream mode, etc., 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 right? And we report how many bytes we've read or whatever, and that's it, right? So that's interesting, right? Now we have a stream here. What can we actually do with this? Well, we can do many things, but what we actually want is we want to turn this into a reader. So I'm going to say reader here, and to reader error, io.Reader. So here you can see there is a function to.Reader that takes a stream and returns a reader and says, was it, fine or not? Right? To.Reader, okay. Here we can actually just say okay. If not okay, let's say return nil reader creation error with our file name and stream. This is just sort of something we have, reader creation error. So here we have file name, this is io.Stream, of course. This should be fine. If I save now, the main issue here is that, well, reader is declared but not used. And so now we have this reader here. What we actually want is a buff io.Reader. So we're gonna go up here and uncomment this. And we're gonna initialize one. Let's say buffered reader, buff io.Reader. Let's just do this. It's fine. Buff io.Reader. This is a different type of reader, just to be clear. When we actually have this to.Reader here, what we have is an io.Reader, which is just a stream, just to be clear. We can see here that it's literally an alias for stream, right? So type-wise, right? So here we have a buff io.Reader though, and we can say buff io reader init here. This is going to initialize this, and it takes a buff io.Reader pointer and a reader, and then a default buffer size, or a buffer size rather, to allocate with and so on. It also takes an allocator. So here we are going to say buff io.Reader and give our reader, and then we can say, for example, 256. Doesn't matter so much here. And we want to pass our allocator here actually. Yeah, so now we've initialized this, right? What more error do we have? This can potentially return an error, read lines error. Here we want to expect this to be nil, like this. And if we look at our test run, we can see nothing has changed here, right? So we want to read lines, right? Let's say we have our lines. I'm gonna go ahead and do something that I don't necessarily love as a thing, but let's just say this. So what I'm doing here is I'm creating a variable that starts with an underscore. That's just because there's no great name here for lines. You could of course just say else here. That would be fine, honestly. But let's just do this. We're gonna actually say this. We're gonna return those. And here we're gonna say or return, because we don't really want to necessarily handle that specifically. And mem is not imported. Right. So now we have these lines. This is a dynamic array, dynamic slice or whatever. What that means is we can add to it, right? So what we want to do here for we want to read a line. Yeah, read the line, bufio. So read error. Let's say this, bufio read reader read bytes, I think it is, right? Yeah. So reads until the first occurrence of delim, meaning a delimiter. We actually want to just say, hey, bufio reader here with these, and then we want to say an allocator here. We want to pass down our allocator. This gives us a potential IO error here. We could potentially just say, hey, IO error here. Potential. Let's see. Yeah. So this gives us our line, and here we can say, you know, if line, no, we should just be able to maybe do this, right? Lines, line, add a line to the lines. Let's see if this is now different. Ah, no. So here we want to say read error here. If read error is equal to bufio or IO error, no progress. We want to break. And here we want to remove the or return. And I'll explain some of this code, of course. Here we can see we are reading lines, in fact. Expected 5 got 6. 1, 2, 3, 4, 5. Okay. Yep. I didn't check this before. Now, of course, we can see here that, yeah, this makes sense. We are now reading the correct amount of lines and so on. We did see that there was an interesting error, right? No progress. So this is just sort of the basic skeleton for the thing that we want to do, right? But we don't necessarily know a lot about the behavior of this function at the moment. We're calling this code that sort of uses these readers and so on, and we don't necessarily have a lot of insight into what they're doing, right? We have this bufio reader here that's doing things, and that is basically initialized with a reader and so on. So what I want to take a look at now is how do we extend some behavior or otherwise, you know, plug in things, right? We saw in this reader definition, or stream rather, that there was this data field, right? So we're going to take a look at sort of this. I want to visualize in some sense what's actually happening in this program. So what we're going to do is we're going to say that there's a function add logging to reader, right? This is a proc that takes a reader to add something to. Let's say base reader, right? So that's an IO reader. And yeah, let's do this for now. We want to return a reader. That's the new reader. We're going to take a look at how this has to be modified and so on. So we know here that the stream here has to have the stream proc, right? So we have to basically copy this, right? And say, okay, in order to create a stream, we have to have these things, right? So we have to have a stream proc. Let's implement one real fast. Logging stream proc. This is going to be private to the file. Doesn't matter so much, of course, right now, but it is just nice to do. And here we want to return something. And this is going to be io.Stream mode, of course. And IOC from, presumably. This can be just return for now. IO error here. And that's it for kind of the skeleton of the thing, right? Now we're going to try to add logging to a reader, right? And there are a few ways to do this. And of course, we're going to create this reader, right? Which means we're going to create a stream, which means stream is defined as data and the procedure, right? So what we actually can do here is just say, we can say, hang on. No, I was wondering if Copilot knew something that I didn't. Sorry. So we want to create a reader with some stuff in it, right? So the procedure is going to be logging stream proc. This one. The data is going to be something, right? And we're going to determine this something in here, right? What do we need in order to log something, first of all? We can see here that this is a normal Odin proc, so it's going to have access to the context, which means we can actually straight up immediately say this. Yeah, let's say this. Yeah, I want to just say this. So we need access to an N and an here, right? And we are going to have to run some kind of, we're extending another reader, right? So we need access to a reader, right? And this is where stream data actually comes in. This is a raw pointer. It can point to anything. In C, this would be a void pointer. And here, what we can actually do is we can use the fact that this is a language that, well, for lack of a better term, it's hold my beer programming, right? You can do the thing that you want to do. It's not going to mandate that you bookkeep literally everything 100% correctly all the time. So what we're actually going to do is just going to say data, right, is going to be transmute a, let's say io.Reader for now, on stream data, right? So now this is going to be a pointer to an io.Reader, right? We know what that an io.Reader has a procedure, it has some data. So what we're going to do is we're going to say n equals data base, well, not base reader, right? Data dot procedure, right? With data dot data. And then mode like this. And so now we should be able to say, okay, we can then print those things. Then we can return n and like this. This compiles. This is our logging stream proc. Right? It's going to look for a pointer to an io.Reader, and that's it. So how do we get the pointer to an io.Reader? Well, here we have an io.Reader, in fact. So what we could perhaps do is say data equals base reader, like this. This is a procedure parameter, of course. So what we want to do is perhaps say here that this is a pointer. Let's do that for now. Now I have add logging to reader. Let's see if we can move forward. Here, this is a file reader. I'm going to name that. Then we're going to say reader is equal to add logging to reader, exactly, file reader. Let's see. Just want to make sure that some of the stuff makes sense. This compiles, and now we get logging. But there's something interesting going on. We initially read 79 bytes, and then we read a bunch of times without reading anything. There's no error, but we are saying basically there's zero progress, and that is what this no progress error was about, right? And you might think like, well, this seems fucking pointless. Sorry, this seems pointless. But what we actually can do in order to kind of mitigate this, I'm not entirely sure exactly how much of this is actually part of the, let's say the actual interface of Odin. But what we can do is we can say in this bufio.Reader, we can actually say, hey, bufio.Reader, max consecutive empty reads. If we set this to 5, for example, we can go to our test and we can see, yeah, okay, now runs 5 times without making any progress. We can actually set it to 1. And now we get, oh, we read 0 bytes and then we had no progress. Once, right? Which is basically what you would expect. We reach EOF, right, end of file. And then we actually have to stop. So we'll note though that the logging here is reporting, hey, this is coming from logging stream proc. And that's kind of awkward, right? I'm not going to say that it's a big deal because it's certainly not, right? But it is a little bit annoying. So what we're going to do is we're going to try to extend this a little bit. So I'm just going to add this thing here called log data, which is a struct which carries a base reader. And this could be actually, let's say it's a pointer to io.Reader. I'm not entirely sure how this is going to, if it's going to be a problem, but source code location, which is in runtime, I think. Source code location. Oppa. Source code location, I think this is runtime. Let's see that. And here we want to transmute now from our pointer to an io.Reader to actually log data. Right, this is our log data now. And we actually have to change this here, right? This is not going to compile anymore. And when we add this logging, we actually have to add, instead of just base reader, right? We're going to have some kind of access to the logging data. So what we're going to say here is log data, which is a pointer to log data. Let's say data here. So that one is fine up there. Now we have an assignment count mismatch here, right? Because this is no longer actually that, it's going to be base reader dot data and data base reader dot procedure, like this. And here we actually have to supply this log data, right? So we're going to create log data here, which is a log data object. And then we're going to pass down a pointer to it. The reason you might want to do this sometimes, create this here, is this is stack allocated, this object, right? I know for a fact that I don't want this logging to happen outside of the scope. So we don't need to heap allocate it. So I can just put it on the stack and then I can give a pointer to this. And then we use this reader down here. If this reader ever escaped this scope, this would not be a good pattern, because we would have a pointer to stack space and this would be bad. And this is the entire problem that Rust solves, by the way. Just want to add that because, well, Rust solves a problem that is the actual problem, right? So here we have our location. So remember we added our source code location here to to the actual data, right? We're not actually passing this anywhere. What we can do here, and a very common pattern, is lock is going to be equal to, assigned to, by default, lock color location, like this. And so now we can basically say, when you call add logging to reader, right? That's where this logging is going to happen, for example. And so now we should be seeing a different result. Let's see here. Failed to run task and so on. Let's see. What are we doing here? Let's see if we can. Okay. Base reader is an io.Reader. Oh, hang on, I am not setting. I'm not setting any data here. That would explain it. So here, data is going to have to be log data with the base reader and the lock that we get. Let's see. There you go. And here we can see the logging is still not using the correct log. Let's see if we can. Data location is a source code location. We're pulling a pointer to log data out of here. Here we create this reader, and let's see here if we can figure this out. Log debug f takes a location as its last. There you go. So this was just to illuminate kind of what was going on there. Debug f is a variadic. It has variadic arguments, meaning it takes some amount of arguments. So we had to disambiguate between what was part of the variadic ones and a keyword argument, which is this location here, right? It's not a keyword argument, but it's a named parameter, right? Named argument. So I have to say location equals data location. I can't just say data.location, because then it's going to try to print this. And the reason here, the reason we have this non-extra here is because there's an extra argument that is not being formatted. So Odin was trying to tell me, hey, there's something wrong. It's just not great at telling me necessarily. So now we actually have our location here, right? And so what I want to illustrate with this is not necessarily you should be logging your reads like this, though it can be useful to kind of as a debugging tool or visualization of what's actually going on. What I actually want to illustrate with this is how we can say we have a structure here, right? That we want to basically store in a somewhat, not a generic function, but this is a function that you're meant to implement, right? The stream proc, right? So this stream proc here is specifically for logging, and the reason we create log data is so we can basically pull that out of this raw pointer. And this raw pointer pattern is basically everywhere. So for example, if we were to go to Odin and we say, let's say allocator, so runtime allocator, this is not the one we want, here. So this allocator proc here, right? If I search for allocator proc, we can see that here. This also has allocator data, right? If I go to logger proc, right? This is a structure that also has data here. And when we create a logger, we can put whatever we want in this data section. So we could call this a data pointer. Right? The pattern is data pointers, right? And so I think it's important to understand that, yes, this is it's a neat thing. But this is a question of usefulness versus safety, right? I think that this is incredibly useful, but we should also understand that, yeah, it's a pattern that we might not want precisely everywhere, because it is fairly easy here to have an invalid pointer, for example. There isn't that much here that actually it's guarding us from potential error, right? To be honest. So we should be aware that it is important to kind of not overuse this, right? I don't think it's the best extensible pattern or whatever. It's certainly not the safest, but it does actually allow us to do a lot of stuff, right? One area, by the way, I should mention, if we go here to threads Odin rather, is that when we use threads, this is actually how we pass things in. So if I look for task here, let's see if I can find the task. A task is a struct with a procedure, again, and a data pointer, right? And a user index and an allocator, right? So when you have a task that it has its own things here, right? And your task proc, right? Much like everything else, is going to be something that takes a task and actually does something with that data pointer, does something with this and so on, right? And so when we use task pools or thread pools and so on, we want to run tasks in these, we have to work with this pattern, right? So here we can see, run this procedure inside of this pool and so on. And so then we pull out the data that we know that we have in this raw pointer. And of course, so we can guard for some of these things, right? If I somehow had some kind of nil pointer here, for example, right? If stream data is equal to nil, right? I could say, you know, hey, but you should just bail out, you know. And that would be entirely valid. There's no way that this is supposed to be nil. Or we could just say, hey, this should return 0 and nil, for example. Right? If there was no stream data set, we're just not going to do any logging. And of course, I don't think that's probably not what you want. If you're adding this logging, there's a reason, right? So anyway, let's go over sort of what we actually looked at, right? So we were reading some lines from a file. And we were doing this like this we open the file, right? We create a stream from that handle. We turn that into our reader. And then we say buff io.Reader, which is going to buffer for us automatically using a backing reader, so to speak. This is going to then buffer stuff for us, and we can then use this in order to read, for example, until we reach some value, for example, right? Reader read bytes. There's also a variant here, by the way, reader read string, that gives you a string if you want. So you can get bytes with this version, or you can get a string with the other version. And so if we encounter, hey, we got no progress, we're going to break because there's no progress, then we must be done. And we append to our lines. And this is how we, this is how we take a dynamic array and actually produce a slice from it. So if you remember from the previous video, we looked at what a dynamic array was. And let's see if we can actually a dynamic array. I'm gonna just show this again. Raw dynamic array. Let's see this. Right, here we can see our slices and dynamic array. And we can hopefully see here that how easy it is to go from a dynamic array to a slice. So dynamic array has some data inside of it. This is not a data pointer in the same sense, by the way. It's just a raw pointer to the data. And it has a length and a capacity and an allocator that it uses. So dynamic arrays always store their own allocator that you created them with. And then a slice has data and length, right? So you can see how moving from a dynamic array to a slice is really just cutting away these two. And then you have the same thing. But anything that takes a slice is going to obviously, like, it doesn't expect a dynamic array. So now we've basically, in some sense, we have, you could say we have upcast this dynamic array to a slice or whatever. We have just said, you know, take away the dynamic portion now. And all we have left is this. We still have the data. The data is in the same place. The length is the same as it was. We just can't add stuff to it anymore. So in some sense, it's kind of like freezing. If you've used Haskell, for example, you have these mutable arrays, for example, and you can freeze them and thaw them, right? So when you freeze an array, it means basically I can't add anything to it, right? When you thaw it, you can now suddenly add. So that would be, for example, we could go from a slice to a dynamic array. So, right, so we have our dynamic array here. We append stuff to it. We turn that into a slice, right? And in this, we were interested in sort of how does the buffered reader do stuff and so on, right? And we noticed that it was doing a lot of reads that returned nothing and so on, right? So we added logging to the reader by basically saying, hey, basically create a new reader, which we know takes a procedure, right, which is our logging stream proc here, and some data, right? And we created our own log data here. The log data is basically saying, hey, here's the actual reader that is the backing reader or the base reader, right? And here's our location that we actually called add logging to reader from, right? And then in logging stream proc, we actually interpret the actual raw pointer as this log data, right? And this is the key to this kind of thing, right? We interpret it. So this is just a cast. It's like casting from a void pointer to something that you know, right, in C. And then we actually run the base reader and report the results. That's what our logging reader is doing, right? And then we actually return those as they are, right? And so the reason we actually have this log data struct here is we wanted multiple things in our data segment, right? Or data pointer or whatever. And so, yeah, I think that's it. This pattern is very, very neat. I think it's, neat is not the right word. It's very powerful. And honestly, you should treat it as such. It's not necessarily for everything. It can be very unsafe. And of course, you just have to basically build structure around it that, you know, maintains invariance and so on, right? So, yeah, I think that's it for this video. It's become very long, but I hope it was informative. If you like this type of content, if you like the video, like and subscribe. It really will help in the future with, you know, continuing making these videos and so on. But yeah, okay. Have a nice day and ciao.